Welcome back. Let's do some practical exercises regarding to our content provider. And we start with our SQL injection attack, which sounds amazing, but it's really not that common anymore. Nevertheless, exported content provider are still pretty dangerous, and we will find out why. So therefore, let's go. Okay, so here we are back at the Ubuntu VM. We've got our smartphone over here, and we once again install the Sieve application because this one has a really nice attack surface regarding to content provider. So within apps, Sieve, yes, here we have it. So we install the old version. I mean, not the old version. We're installing the APK and not the decoded version. Okay. And I guess we have to set it up first, which is a little bit annoying, and therefore I will fast forward this process. Yes. So we want to give access to files and media. And then, yes, we have to set it up. And we also get still this warning, but it runs on the smartphone perfectly. So I'm using a Nexus device in RP version 30, and this works properly. Okay, so I will fast forward this process right now. Okay, so here we are back and we have already set up this application. Okay, so we've got the service in there, we've got a password, we've got a PIN and a bunch of other stuff. So therefore, let's have a look how we can exploit this content provider in there. So therefore, we are having a look into the Android manifest. So within the decompiled version, we still got it over here. Here we have the Android manifest XML. Yes, and here we can see we have two content provider, this one and this one. Okay, in this video we will have a look into this content provider, which is simply just a database interaction, and this one over here, this is a file provider, which gives us the possibility to search for path traversal vulnerabilities. All right, we will do this in the next video. For now, we focus on interacting with a database. By looking at this one, we do not know if it's in database or if it's in file provider. So we will have to take a look into the source code to figure this out. But before we do this, let's first discuss this here real quick, because there's a bunch of stuff which is pretty interesting. So therefore, let's get back on the graphic tablet. Okay, so here we have our content provider, this one over here. And we've got the authority name, which is this part. Okay, and then we've got exported true. Amazing. This means this content provider is available from the outside world. We can interact with this one. So that's good to know. Multiprocess will be ignored, and we've got the Android name. So this one over here, this is the class name. It has been defined in here, and this is something we want to check out later on. I mean, we haven't talked about reverse engineering yet, and therefore I will do the reverse engineering approach and provide you the decompiled source code. It's not the original code, I cannot find it anymore online, but it's good enough to perform our reversing tasks. Alrighty? Okay. So we know we've got a DB content provider class, and this is the authority name, which means we've got something like content : / and then com MWR and so on. Okay, and then we've got this part maybe also included over here. And now there's an interesting part, because we also got this line, and this line is now a path permission. So this one is telling us we've got now a database. This is our content provider. I mean, we do not know this right now, but this is something we will figure out in just a moment. So we've got a database. And this database has now different tables. We do not know how many, but we can already see one, because this one over here, this is the, wrong color. This one. This is now the table, and let's clean this up, the table keys. Okay, to be more exact, the table name can be still different, but this is that's the scheme, the URI, to access the table. Okay, so we've got a table in here that might be keys, or it could be also named completely different, but we can access it via this URI. Okay, but why is this one listed over here separately, and what's about the other tables? Well, this one has been listed separately because we've gotten custom permission for this table. This means if we want to read or write to this table, we need to have this permission. This one and or this one. Depends on the action we want to perform, of course. And those two permissions are defined over here. So now we are dealing with custom permissions, which means the content provider is being exported. So this one over here, this is exported. But the keys table has been locked down. The keys table is being protected by those two permissions. We can include those two permissions in our own application. And if we ask the user nicely, then the user might grant us the permission, and then we can access this anyway from our malicious application. In this part. But we've got this protection level dangerous, therefore the user might get a pop-up. It depends on the Android version and the smartphone we are running. But normally speaking, the user should get a pop-up over here. So there should be some pop-up. Do you want to give access for this app? And the user has to accept it. To be honest, I wouldn't count this as a big deal because the user might easily get those permissions to our application, and then we might be able to access those sensitive data anyway. So therefore, inserting custom permissions with a protection level dangerous, I guess that's not a good deal. At least that's the way I see it right now. If the protection level would be something like signature, then we're talking about something different. So that's a totally different story. This would be perfect. We will talk about signature and the signing process in another topic. So far, it simply just means if we have an application and another application has been signed with the same key, then those two can exchange information easily. But this, of course, excludes other applications. So it always depends on the use case the developer wants to do, or on the data the developer is providing over here. So it always depends on the type of data we are sharing. If those data are critical, for example, if these are our passwords in our password safe, then protection level dangerous might not be sufficient enough. We should go for signature. But if they are being encrypted anyway, then dangerous might be still okay. All right, so it depends on the data itself. Okay, but back to this one over here, which looks like a complete mess. So maybe let's clean this up and summarize it over here real quick. So we've got a database and we've got this authority name. This one, this is our class, which is defining the content provider. And this has at least one table. And this table can be addressed in the following way. Content slash, then our authority name, and we've got this path keys. Wrong color, let's be constant. And that's in capital K. Okay, this keys table is being protected with these two permissions, which is not a big deal. We can circumvent this. We will also do this later on. We will write our own application and include them into this application. But for now, at least, it is protected. So the user might have to grant this permission. Okay, so now I would suggest let's decode this app. So let's get back the source code and let's have a look into this class to see what's going on over here. Alrighty, let's do this. So I clear the screen and then, okay, I'm using the JDX tool. If you want to follow this, let me get the help first. Okay, if you want to follow this, I recommend using the JDX GUI tool because there you have some connection between those classes. You can simply double click on something. But we haven't talked about reverse engineering yet, and therefore I will provide you the source code. I mean, it's the decompiled code anyway. So this will be our workspace, and therefore I go for the JDX command line tool. All right, so how can we do this? We've got JDX. We need to provide an input file, which is sieve.abk, and then simply defining an output directory, and that's all. So decompiled code. Okay. We could also limit it to just have the sources and not decompile those resources, but we stick all together. So all in this directory. Now we can open the whole directory with Visual Studio Code. Okay, so this is exactly what you will get from me right now. These two directories, the resources, which includes the Android manifest, and also the sources, which contains the source code. So let's see, which class do we have to look for? We need to take a look into this one, DB Content Provider. So let's find this. Okay, it's not that hard. There we already have it. All right. Yes, okay, and here we can already see we've got the content scheme. So exactly like we have written it down before. So by using this scheme in exactly this way, with this DB content provider /keys, we are addressing a table. But the table doesn't have to be named exactly like this one. So it could be keys, but it could be also completely different. This is some kind of alias for a certain table. All right? Okay. For now, we do not have to bother too much about this because we will figure out how to deal with this later on if those names doesn't match anymore. Okay, for now we can see we've got one content URI, so one alias for keys, and we've got another table over here, passwords. I mean, once again, it hasn't to be named passwords, but that's the alias name for this one. All right, so at least we're dealing with two tables, and now we already got something interesting. Our content provider is being exported. Keys has been locked down, but passwords is free. So at least we should be able to query this one, this reference, whatever's inside here, and get out these data, which is super amazing, right? If they are interesting, those data. So we will have a look into this one later. Okay, and then we've got a bunch of stuff. I mean, these are references, IDs, who knows? This one over here sounds interesting. We've got a PWD helper. So maybe let's get this a little bit out. Okay. And then we've got a URI matcher. So this matches our URIs from here. Here we can see we've got URI pass. Okay. And then let's see. All right. And then we've got our familiar methods. So on a first view, it looks like a complete mess, but you do not have to bother too much about this. And let me get back the graphic tablet and then I will show you why. All right, so if you still remember the theory part, then we've got our content resolver on the client side, and the content resolver is asking the content provider to provide some access to the data. The content provider is returning back some cursor and also giving access to those methods. So here we've got the method delete, for example. So this is simply just deleting an entry in a table. Beside this, we also got insert. This one over here. So here we can insert a new value into a table. And then we've got query. This is maybe the most interesting part right now, because here we can see we've got now all these 5 parameters. We've got this URI, we've got this projection, we've got selection, selection args, and sort order. So out of these parameters, an SQL syntax will be formed. So we're having something like select. Then we've got our projection from. Then we've got our this one, our in. Oh, wrong color. Let's make green. In. And then we've got where. And we've got all the rest. Selection, selection args, sort order. So out of these parameters, this SQL syntax is being formed, and this is exactly our injection point later on. This part over here, this projection. But we will discuss this later. For now, let's finish the discussion of this file over here, and then let's see if we can already reconstruct the database and also the tables based on the source code. Because if you want to perform an injection, we need to be familiar with the structure to name it correctly, otherwise it won't work. Alrighty? Okay, so let's clean this up and let's see. Alright, so yes, we have talked about the query and also about insert, and this one can be ignored right now. The part above has been also analyzed. And this one is interesting because here we are now having a method on create, but this time we are not having the activity on create method. We might have a creation of our database, and this one is pretty important because if we are creating our database within this part over here, Then we can make some conclusions about the structure of our database. Which tables are in there? What are those columns? And how they are being interconnected. So this is something we definitely want to figure out. And therefore we will have a look into this one afterwards. Okay, after the query method, there's only the update method left, and this can be simply used to update our entries in a table. So all of this will be done later. We will play around with insert, delete, and also update statements, and of course our query statement to inject our own SQL syntax into this one. All right. Okay, before we can do this, there's only one task left, and this is this one over here. So therefore, let's figure out what's the structure of this database. Okay, so here we have the PWD helper. Let's see, PWD helper is over here. Okay, and this one, all right, this is defining the database name. So within the data directory, we're having our package name. And in there, we're having a directory named DB. And this is the file in this directory. So this database will be stored in there. We could download this into our laptop, in this file with a DB pull. First, we have to place it on the SD card, but then we can download it. And we can use tools like SQLite browser. I guess it's SQLite browser 3. Or simply the command line tool for SQLite. And then we can access and query this database and can find out the structure anyway. But we can also do this over here because it might not have been initialized completely, or there might not be any value in there. So therefore, let's also do the reversing approach, but nevertheless, feel free to try this one over here out. Okay, so far there's nothing interesting until here. And here, once again, we've got another onCreate method. And this time we've got something PWD, PW table, this way. So we've got PW table, and here we can see SQL create entries. All right, and this one is not being referenced anywhere, so it might be in static field. And therefore, let's have a look into this class over here. And we can find this here. All right, let's open it. Perfect. This is the final structure of our database. So now we've got everything completed. We've got a database file which is named database. I'm not sure anymore. It doesn't really matter. So this is our database. Okay. The database name was part of the authority. So I guess DB provider. And we have to look it up in case if it's wrong. DB provider, that's the name. And here we can now see we've got table. Here's the table name, passwords. So we've got a table named passwords. And we also got a table named key. And this one is now interesting. Key. Because if you remember the content URI regarding to this key table has been referenced with keys. So the reference is this content URI keys. This is the way how we access this table within content provider. But if we are using it within an SQL injection, we have to use the correct name of this table name, which is key. So not the content reference, we have to use the correct table name. So this one over here, this is simply just an alias for our content provider to access this table. All right? Okay, let me clean this up. Okay, and now let's see, what entries do we have? We've got email, password, service, username. And for now, we do not know if they are in password or in key. Here we've got password once again. Okay, interesting, but they are also named different. Capital P, lower p. Here we've got PIN. And then, yes, this is what I was looking for. So here we've got now create table key, and we can see this table key has a column password, which is text, which is the primary key, and it also has a PIN, which is text. So this one has now two columns, which is password and PIN, and both of them are text. So this could mean that they are being stored in clear text. It could be also encrypted and base64 encoded, for example. Then this text parameter would also make sense. So this is something we need to figure out. But we can already see the structure of our table. So our table key has the columns password and PIN. Okay, and then we've got this create table over here. And let's see. Okay, this one is for our password. Yes, this is for our passwords. And this one has a lot of entries. We've got an ID, which is the primary key. So there will be in column name ID. There will be also in column name service. There will be in column name username, password. Interesting, once again password. Here lowercase, here capital. And this time the password is blob. So this means it's binary data. So this is most likely being encrypted. Okay, and last but not least, we've got this email. All right, and these are the things we have already figured out just by reverse engineering a few classes. So we know the database, DB provider. We've got two tables in there, and the most interesting one is the key table, but this is also the one which has been locked, so we cannot access this. All right, so far so good. Our attack vector is now the following. So the key has been locked. Okay, but the lock is only available from the outside world. So the DB provider has been exported. And if we come from outside and we try to access this, then we get a deny. If we are not having the permission to access this one. But if we are able to query this one, the passwords table, then we are already in. So this lock is not taking place anymore. And if we now can smuggle our own syntax, our own SQL query, whoops, query is, I guess, written something differently. That's the way. If we now smuggle our own SQL query into this passwords, then we might be able to access this. So this is our attack plan. But before we do this, let's first find out how we can interact with this one. So how can we query those tables? And in this case, the passwords table, because the key table cannot be queried. And this is also something we will find out right now. All right, let's do this. Okay, so to do this, we are using once again the ADB shell. And this time we're not using the activity manager. This time we're using content. Let me close this one. Okay. Okay, so on the first view, it looks like a complete mess. Complex parameters, things we do not know right now, what is extra binding and things like this. But we can make this a little bit easier. Those lines over here, if the text starts over here, then we've got a new chapter. So this one is ADB shell content insert. So here we are dealing with inserting new data. Here we can see we've got update. And this one is delete and this one is query. And then we've got content call, content read and some other stuff. The second half can be simply ignored right now because this is regarding to file access, which will be discussed in the next video. There we will find out how path traversal will work. For now, we only focus on the first half of this one, interacting with a database. And now we know we are dealing with a database, at least for our content provider over here, in this one. Where do we have it? Here. This one, this DB content provider. All right? Okay. So maybe let's put this on the right. Let's close this. Okay. Okay, so now's the question, how can we access those tables? So within here, we are now having a database, which is stored in a protected directory, but the access to the database API, to the content provider, is being available because it has been set exported true. So to do this, it's very easy. All we need to do is we need to use content, and then let's see, query. And then we do not have to take care about all these complex parameters. I mean, we know what projection is, how and where statement works and things like this. But we do not have to take care about this because if we are not applying any parameter, then we are simply selecting everything from this table. Easy, right? Yes. So how can we address this table? Well, all we need to do is we need to provide content. I'll write this down as a comment over here. So content, and then the authority name, which is this one. And then slash and the table name. This is how to access this table. And we do not have to do this on our own because this is already being defined in the DB content provider. So if we scroll up a little bit, yes, here we have it. So here we can see we've got content, our authority, and then the table name. Perfect. So we simply copy this part and we are inserting over here. And this is how to perform and select all from the passwords table. Nice, isn't it? Let's do this in 3, 2, 1. There we have it. Nice. We can see we've got the service banking, username admin, password blob. We can extract the binary data out of this because now it's just saying, okay, this is binary data and it's not displaying it, but we can deal with this one. Nevertheless, those data are being encrypted. So we do not get an advantage out of this unless we can decrypt it, which is not possible right now because we do not know how to do this. And it might be also protected with the user password, which makes it even more impossible if the user password has been chosen correctly. So these are many what if cases. And this is something we do not want to discuss right now. We will have a separate section about this cryptography, but for now we want to talk about content providers, okay? All right. So last but not least, we've got this email, which is an information leakage. And if you take a look at the structure, _ID, service, username, password, email, this is exactly what we have reversed engineered. So all we need to do is simply following down the line of our content provider, because there it's being defined how to access the database and also how the database is being created. So there might be some reference to this. Alrighty? Okay. So this is a way how to interact with this one. And what happens if you try to access the protected ones? The protected ones is keys. And this one over here. So let's see. Now we want to query this one. And here we're getting now an error. Let's make this a little bit larger. Okay. Permission deny, what we expected. And here we can see we try to access the keys from which is this process ID. It really doesn't matter. All it matters is we are trying to access this from the user ID 2000, which is our ADB shell. And this one over here. So the ADB shell has not the permission to query this. If you would get root privileges, then of course this is possible. But then it's also not an attack vector anymore, because then we could simply go into the data directory and directly access the database. All right? Okay. So within the ADB shell, we are not having access because our ADB shell does not have those two custom permissions. These two. All right. So now let's see how we can still access this table based on an SQL injection. And to be honest, this might be the only use case where an SQL injection is useful, because otherwise we have seen this with the passwords table in this one. So we could simply access those data if the content provider has been exported. And in most cases, the developer is separating this. So the developer is creating two databases, one which is being protected, so completely, and one which might be exported to interact with other applications, but then those data are not that sensitive anymore. And if we find a flaw in there, it doesn't matter because we cannot access the other database. All right? So this is the things we most commonly encounter, but nevertheless, let's talk about this, because if you have this case, then it might be an absolutely nice finding. All right. So how can we abuse this right now? Well, if you go back, and then we've got this query, and this one over here. So out of this query, an SQL syntax will be formed. And this is something I guess we should discuss on the graphic tablet once again. Okay, so I will discuss SQL injection on a very high level. In case if you're not familiar with this and you want to have an extended version with union, blind, time-based, stack queries, and even more error-based is missing. If you want to have all of them in a separate video, please drop me a message in the comments underneath this video and I will upload a bonus video regarding to SQL injection. But this is something which would extend this video very heavily right now, and therefore, yeah, if you are interested, I will split this and provide you those information. But if you're already familiar with this one, it would be super boring for you. So therefore, we just discussed this on a high level. Okay, so out of this query right now, with these parameters, this one, this one, this one, this one, and this one, an SQL syntax will be formed. And this one might look like the following. Select. This, by the way, is the URI we are passing to this one, and the URI we need to pass is passwords. Because this is the table we can access right now. Keys is being blocked, so therefore we need to access or provide passwords for this. Okay, and then we are having an where clause, which can be simply ignored right now, because over here those selection args and things like this would be normally used in an SQL injection. But over here, we can directly define this projection part, which means we can directly insert SQL syntax into this query, which is absolutely amazing. So what we could do is the following. If we provide a projection, something like this, projection, and a single quote, then we are having select, oops, yeah, let's write it in this color, it's okay. Select, then we've got the single quote, this color, from, and so on. And single quote will interrupt the SQL query. So the SQL syntax is awaiting another single quote somewhere. Otherwise, this from will be inserted into some single quote, which means this might be treated as some string. And therefore, if we are only having one single quote, then we are getting an error over here because the single quote is missing. We are intercepting the original query, and we are not closing it right now. So this will lead to an error. Let's find this out. So let's close this. Okay. Let me get this graphic tablet out of the way real quick. All right. So how can we apply this projection? Well, if you're using content and then have a look in the help menu, where do we have query? Over here. And then we've got this projection. So we can use -- projection to apply our projection. Okay. If we are applying this in the following way, then we can see the terminal over here is expecting to end the string right now. And exactly the same happens in the SQL syntax. So if we close this right now, then we are getting an error while selecting from passwords. The single quote, if we are inserting it in this way, it will mess up the terminal. Therefore, we have to use double quotes left and right from the beside the single quote. So this will now bypass our ADB shell terminal and insert a single quote directly into the SQL syntax. All right. Okay, so let's do this and let's see what happens. Oh, nice. Unrecognized token. Here we can see exactly like we have written it down before. Do we still have it? Let's see. Yes, so here we still have it. Select and this one. So here we have opened the query. And now it's complaining about this path that this one is not being enclosed. So we have interrupted the original query. All right, how can we use this? Well, this is now our point where we can apply our own syntax into the original syntax. And afterwards, we just have to fix the original query. And this can be easily done by applying a comment. Let me show this to you. So if we are inserting something like this in the projection, not the single quote anymore. So let's get rid of the single quote. If you're now inserting something like this from passwords, from key, and we have to take care about key, so how it's being written correctly. So uppercase, lowercase, and it's not keys. Keys is the reference in the content URI, but the table name is key. And here we have to be precise because we need to address the table name. We are not within the content provider URI anymore. Okay. So if we inject our own SQL syntax, we have to stay or stick to SQL syntax, which means SQL needs to know the original values. Okay, back to this one. If we are providing projection, asterisk from key, and then 2 hyphens, this will comment out the rest, which will lead to the following syntax. And so here we are having select, and now we are inserting all from key hyphen hyphen, and this will lead right now to the following. So afterwards we are having, let's see, we are having from passwords, and where, and so on. So everything afterwards will be now commented out. So this will be simply ignored. And the only syntax that's going to be executed is this one over here. So select all from key. And this via the password table, which can be accessed, because this one is not being protected by the custom user permission. Alrighty, let's try this out. Okay, so let's see. Over here, yes, projection, all from key. And this is all. 3 to 1. Yes, I'm missing the hyphen, because then now we can see this perfectly. Select all from key from password. This is not valid SQL syntax. Therefore, we have to comment it out. It was on purpose, of course. So let's see. 3 to 1. Nice. We've got the password in plain text and also the pin in plain text. Amazing, right? So this is how we can circumvent the custom user permission based on an SQL injection. And to be honest, this is the only use case I can think of an SQL injection being useful in our Android app, because otherwise we would be able to query this anyway, right? All right. Nevertheless, I think this could be a pretty amazing attack vector in case if the developer is putting everything into one single database and providing partial access to this one. Beside this SQL injection, we are also having another issue. And this issue is over here. So this custom user permission is being defined for the path / keys, which means if you try to access this one, at the beginning, I guess, yes. If you try to access this content URI with the path / keys, then the user permission will be checked, and in case if we are not having it, our access will be blocked. But this path has not been defined in a regular expression, which means if we are accessing these keys in a different way, for example, let's clear this, content query over here. So this is the normal behavior, which gets denied. Oh, yes, -- URI. There we go. Yes, access or permission denied. But what if we are accessing it in the following way? Keys /. Then, oh well, we still get the password. So if the developer is not providing a regular expression, if the developer tries to block the access based on /keys on a hard-coded value, then we might be able to circumvent this. But to be honest, I'm not sure if this is still possible regarding to writing an application like this and uploading it to the Play Store. So Google might deny the upload for this application in the official store. And therefore, I would assume that this doesn't happen often anymore. In case if you think, okay, we can simply use /keys and /keys/ as a path, this still doesn't work because we can apply many slashes at the end over here, and then we can still access this. So the only solution for this one is providing a regular expression and not just checking /keys. We should check /keys and then everything else. All right? Okay, so this is all for the SQL injection part right now. Now let's have a look how we can interact with a content provider. So let's see how we can insert, delete, update, and query we have already seen. Yes, insert, delete, and update certain entries in a database. Because the syntax is a little bit complex, yes, but once you have seen this, it's also included in a cheat sheet, it's not that hard anymore to get back on this with the help menu. All right, so let's see. We've got this table's passwords, this one over here. Okay, so let's see how we can insert new values into this one. So therefore we are using content. So we need to use the help because otherwise this won't be possible. It's a little bit complex, but yeah, we will make this. Okay, here we've got content insert and now we've got -- Yuri. Okay, so we have to provide our passwords table. This user ID, I guess, can be skipped. Yes, we skip this. And now we've got this binding, and this is important. Binds a typed value to a column and is formatted in the following way. Column name, type, and then the column value. So this might look a little bit complex, but if we open the passwords, this one over here, then yeah, let's do this. Okay, we already start with insert for this large table, which is, I guess, the most complex syntax. So don't get frustrated. Afterwards, it would be way easier. All right. So nevertheless, let's do this. So if you want to insert a new entry, let's see, content insert. Okay, then we have to provide the Yuri, which is this one. Yes, I see my typo. Okay. And now we have to use this strange bind. And I guess there's always an example. Yes, here we've got it. So this one over here, name is the column name, type is string, and then we've got the column value, which is new settings. Okay, so if you want to insert a new entry, we have to do it in the following way. Underscore ID, this one cannot be used because this one is the index and its primary key and it will be auto incremented. So this can be skipped. But then a new service has to be entered. Okay, so our service is the column name. Then we have to define the type, which is string. And then we have to define the value, which is the new value we want to insert. In this case, height. Okay, then let's see, we want to define a new username, string, and the username is lead. And then we want to define a new password. Okay, now it's getting interesting. I guess it's B for byte, but I'm not sure. And we provide 0. And then I'm not sure about this one. Maybe I have to look this up later on, but let's try this first. Okay, and then we have to use email column name with the value string, and this is hacked at lead. All right, let's see if this one works. So let's enter this in 3, 2, 1. Okay, we are not getting an error, which is good, I guess. And to verify if this works, let's query this once again. Yes, nice. So we can see, yes, we have inserted a new entry. Nice. Unfortunately, it might not be helpful because this password is binary data, and if it's being encrypted and it cannot be decrypted when we are logging in because it's not a valid encryption, then we will get an error. Nevertheless, let's see if we can set this password to be empty. Maybe then it might work. So this could be also a way to entering the application. And let's see. To update this password, so if you want to change the password, we have to use a new query, which is the update query, which is pretty good because that's why we are here. So content update. Let's see how update is being used. Over here. Okay. Once again, we have to apply the Yuri. Whoops, the complete Yuri. Okay, and let's see, update. Update is nice because we have a where statement and we've got our bind. Okay, bind once again, column name, type, new value. So bind is the column name, which is our password. The type is B. And we are not applying any value. I hope this works in this way. So if you're not applying any value, I hope it's null. Okay, and then we have to define which query we want to update, which column. Therefore we have this where statement. And here we have it. Okay, let's copy this. Okay, where, and now password. Oh no, password, this might be too risky. Let's say where ID is equals 2. So this is our row ID2, and now we want to update the password in there with a new byte value, which is nothing. I'm not sure if this works. Let's see. 3 to 1. Okay, no errors. Let's query it once again. Okay. Okay, so it seems to not work, unfortunately. It might be that updating the password in this way, we have to provide a new value. So to figure this out, let's change another thing. So let's change the service, which is in string, and we want to change it in this part. So that's the column name. And now it has the value hacked, and we named it hacked again. And we want to change the service, which has the name hacked already. This one. So let's see. Where service is equals hacked. And so this should definitely work. I'm pretty sure it works in this way. Let's see. Okay, content update 3 to 1. No error, but I mean, we didn't get any error so far. Yes, okay, it is a problem with the password and the byte value because we can see we have changed the name. We can also change the name of the first account, which we do not have access. So service account hacked, where the name. So now we want to change the banking name. All right, let's see. Yes, it has been changed. So let's log in into this application and verify this. So here we have the app, input text, and then I hope it was this password. Let's see. Yes. Ah, nice. We have created 2. So this is interesting. Okay, here we can see account hacked and hacked again. So we can modify existing data in there, which is, I guess, not good because, yeah, even if the password is being encrypted, we might be able to apply some null value. I will check this out and provide this in the cheat sheet if there's a solution for this one. So yeah, by inserting a new account, we might be able to bypass this one over here. Oh, yes, I realize right now, even if we could insert a new account, this password is different. So that's not the password of the application, it's the password of the password safe. So sorry for this, I got confused by having those 2 tables with the same entry. My fault. Okay, so even if we could create a new account, we cannot circumvent the login screen because the login screen is being defined in the keys table, not within the password table. All right? Okay, not to confuse you, but to sum this up correctly. I mean, we could use our keys bypass to circumvent the login screen. And this is exactly what we're doing over here. So I have added this sequence right now. We simply check what entries are in our keys table by using the bypass. And then we can update or also insert new one. In this case, we simply insert a new entry. And then it's a little bit interesting because there's only one entry for this whole application because we cannot have multiple users. Which means we are now having 2 entries, but we can see the password which we have entered will be used to log in into this application. But if we can tamper with the keys table, then I mean, yes, we could simply read out the original password and log in into this. Therefore, I haven't counted as an login bypass at the beginning right now. And I still won't do this, okay? So reading out the password, then, I mean, we do not need to bypass this by entering or updating the old entries. Alrighty? Perfect. Okay, last but not least, we've got this content delete. Where do we have it? This one. Content delete. So how does this work? Okay, we just have to provide the where statement. Okay, this is easy. Let's get back the passwords. Okay, now let's delete, for example, the second entry, this one over here. Content, and then delete Yuri, then we have to provide this, this Yuri. And I guess we need to be careful if we hit enter. I'm not sure if you delete everything in there, could be possible. And now let's see where. So content delete, where, and then we simply copy paste this one. Okay, where, and now we need to identify this database entry. So yes, where service is hacked again. Okay, it should disappear, I guess. Maybe we have to refresh this view. So if you go into settings maybe and back. Yes, here we can see it has been deleted. All right. I guess I misclicked. Yes, I guess I misclicked. So we have seen how SQL injection works with content providers. We have seen how we can insert, update, and delete entries. And we have also seen that we should provide a regular expression over here. What we have not seen is I'll be using this part right now. And I guess, yes, let's do this in a very quick bonus video afterwards. So there we will write an own application which grants the permission over here and then simply access those keys. All right? Okay, in case of any questions, feel free to drop some comments underneath this video. And otherwise, I'm looking forward to see you in the second part of this video where we exploit this with our own malicious application. So, see you there.